Now let us discuss about interlocking concrete block pavements. These interlocking concrete block pavements, or ICBP, are used for footpaths, cycle tracks, residential streets, parking lots, fuel stations, junctions, toll plazas, bus depots, container depots, and roads in high altitude areas, also for industrial floorings. There are some advantages when you use this interlocking concrete block pavements. Number one, they are precasted. The blocks are precasted, hence high quality. These ICBPs restrict the speed of the vehicles, and they are more skid resistant. And this can be used for uh, um, for digging. I mean, wherever for utility lines, because you can remove them and reinstate them once your repair is over. That is the biggest advantage. And these blocks are unaffected by oil spillages, can be used for heavy loaded areas. They give good appearance. Blocks gives good appearance, and they are free from cracking phenomena. And they also act as something like permeable pavement, so that the groundwater can be replenished. We can reduce storm water runoff, or even sometimes we can reduce the number of cross drainage structures. Having said some of the advantages, there are some limitations also for this interlocking concrete block pavements. Cannot be used in high speed facilities because they got more joints. Generally, the riding quality is poor for the ICBPs compared to other pavements, and noise generation is high compared to other type of pavements. So these are some of the limitations. And in this figure, you can see the shape of the block. You can have any shape you want depending upon your convenience and like. And this figure shows the typical cross section of a interlocking concrete block pavement. You can see the sub base here as per the design requirement, and the base layer here again as per your requirement. And above the sub base and base, there you can see the sand bed, and above that we have the ICBP, interlocking concrete block pavements. Now let us look at the dimensions. So there are some guidelines for the dimensions of these blocks, ICBP, interlocking concrete blocks. The surface area need to be between 5,000 to 60,000 square millimeter. The horizontal dimension not to exceed 28 centimeter. The mean length, the ratio of mean length and mean width should be smaller than 3, should be greater than 1. The thickness can be anywhere between 60 mm to 140 mm. The length by thickness ratio need to be greater than or equal to 4. We can use different blocks having varied thickness, different thickness for different traffic. Let's say if the traffic is light, or for light traffic, we can go for 60 thick concrete blocks. For medium traffic, 80 blocks can be used. For heavy traffic, 100 to 120 blocks can be used. So this is in this figure, you can see, I mean, this is a typical cross section for footpaths, car parks, and cycle tracks. So this is the subgrade. This is the base layer of 200 Base layer can be WBM, WMM, or crushed rock, or even it can be soil cement. So above that, 20 to 30 sand bed, and above that 60 thick concrete blocks. This is the typical cross section for footpaths, car parks, and cycle tracks where these interlocking concrete blocks are used. And this is another typical cross section for heavy traffic volume. So again, you have here the subbase for light traffic. This was not there. So here you have a subbase layer, you have a base layer and sand bed layer of 20 to 30 and 80 to 100 concrete blocks are there. So this is typical cross section for heavy sections. The thickness of blocks is more here compared to light traffic. So as I have seen in the previous figures, we had to lay the sand bed above the base layer or below the concrete blocks. So this sand bedding varies from 20 to 40 depending upon the traffic. And what is this sand bed does? It acts as a cushion between the bottom base layer and top concrete blocks. And it permits uniform level surface. It permits the sand bed allows a uniform level surface so that the blocks are not, I mean, are laid on a uniform surface, even surface. So the sand bed acts as a barrier for propagation of cracks from the bottom layer or from subbase or base layers. It acts as a barrier so that cracks are not generated from it retards the cracks. The lower part of the joint filled with sand gives added interlocking effect. Above the sand bed only the blocks are laid. The bottom portion of the joint are filled with sand bed. So this gives an added interlocking effect also. But again, we need to take certain precautions when during the sand bedding operation. So varying thickness of the sand bed results in non-uniform uneven surface, and grading of sand is very important. We cannot use the sand whatever we like. So there is a defined specified gradation for the sand bed. Only that graded sand to be used. That is very important. And the sand, of course, need to be free from silt and clay. And the width of the joint need to be 2 to 4 So in this figure, you can see some blocks here in the edges. These are concrete blocks, and in the edge you can see here, especially here, you can see some concrete blocks. They are called edge strips. Edge strips. Other side, if you see, we have the curb again act as edge restraints. Edge restraint. These two are curbs. And this side, you can see there is no curb, but the other blocks are constructed here. These are called edge restraint blocks. So this provides stability to the blocks so that these blocks do not move, do not uh, come out when there is disturbance due to braking or maneuvering of vehicles. So these edge restraint blocks acts as, I mean, uh, blocks counteracted at the edges. These blocks are counteracted at the edges either by curbs or edge blocks. And the strength requirement for these blocks is 30 MPa after 28 days. So these blocks are very important. So they give edge restraint. So this is the design catalog for pavement thickness as per IRCSP 63. So depending upon the traffic and the type of the road, the thicknesses of the blocks, sand bed, base layer are given here. So depending upon the subgrade CBR, depending upon the traffic or the road type, this composition of the subbase, base, sand bed and blocks are presented in this table. Let's say if it's a cycle track or footpath and the subgrade CBR is above 10, then blocks 60 mm thick, sand bed 20 to 30 mm, base layer of 200 mm. Even if the CBR is between 5 to 10, the composition remains same as that of CBR of 10. So if the traffic is less than 10 million standard axles or residential streets, blocks can be, concrete blocks can be 60 to 80 mm, 20 to 40 mm sand bed, base layer of 250 mm, sub base layer of 200 mm, both for CBR 5 to 10 and above 10. The traffic is between 10 to 20 million standard axles, and for bus stops and for truck parking, industrial streets, almost the same composition holds good. Blocks can be 80 to 100, 20 to 40 mm of sand bed, 250 mm of base, 200 mm of sub base if the CBR is above 10. Otherwise, it is 250 mm of sub base if the CBR is between 5 to 10. So the difference between here and here is block size is increased. When the traffic is increased, the thickness of block size is increased, and for less than CBR less than 10 or 5 to 10, the GSP of 250 mm to be constructed. So for the traffic between 20 to 50 million standard axles are for arterial roads, blocks of 80 to 100 mm, both for CBR 5 to 10 and above 10, sand bed 20 to 40 mm, base layer can be 250 mm, both for CBR 5 to 10 and CBR above 10. Here, base layer we can use 150 mm granular layer like WMM plus 75 mm dry lane concrete. So that option also is there. That also can be looked into. So sub base 200 mm if CBR is more than 10, 250 mm sub base if the CBR is between 5 to 10. So coming to the mixed design aspects, water cement ratio can vary from 0.34 to 0.38. Quantity of cement mix not less than 380 kg per meter cube, not greater than 425 kg per meter cube. We can use fly ash to an extent of 35%. The aggregate cement ratio can be from 3:1 to 6:1. Coarse aggregate, fine aggregate ratio can be, proportion can be 40:60. Size of aggregates can be between 6 mm to 12 mm. Strength of the blocks to be above 30 megapascals. And this is the gradation of the bedding sand. 9.5, 100 mm passing, 4.75, 95 to 100, 2.36, 80 to 100, and 0.075 micron, 0 to 10%. So this is important for bedding sand. This sand should uh, fulfill this gradation requirement. And then there is another type of sand that should be used. One for bedding, other one is for filling the joints. The joint filling sand should fulfill this gradation: 2.36, 100%, 1.18 mmC, 90 to 100, 0.6 mm, 60 to 90%, 0.075 mm, it is 0 to 100%. So this picture tells about the drainage. These are the blocks. Of course, we have camber so that water flows to the edges. And you can see here a permeable, no fines concrete block or permeable concrete block. And this is our sand bed. Whatever the water gets into the sand bed flows and gets into this drain through this no fines concrete block. So this option also can be tried for the design. And another possibility is geotextile can be used around this no fines concrete block so that the blocks are not choked. Choked. Different designs. How do we construct ICBP? So we have to prepare the subgrade, and the thickness of each layer of the subgrade can vary from 100 to 150 mm. Please remember, if you cannot use bigger rollers, then this is to be followed. Because of the constraint area, restraint area, bigger rollers cannot be used. We may use plate compactors, handheld rollers, walk behind rollers. In such cases, the thickness of the layers, lift thickness of the subgrade layers need to be in this range, 100 to 150 mm. The tolerance for the finished quality of the subgrade is plus or minus 15 mm when checked using 3 meter straight edge. Subbase and base layers are constructed as per the specifications which we have discussed already. And the third step is, after constructing base layer, you have to place the bedding sand. We know the gradation. So we should ensure there is uniform moisture content in the bedding sand, and thickness also need to be uniform. We cannot vary the thickness of sand bed, which results in uneven block surface later. So the sand bed, they need to be compacted using appropriate compactors like plate compactor, walk behind rollers. Once sand bed is ready, then we have to lay the blocks. We should start laying the blocks from lower edge to upper edge. Lower edge to upper edge, and we can follow any of the pattern. whether stretcher or herringbone. And in case if we have to use cut units, and that cut units not to be less than 50 mm. So this picture tells about the effect of using a, uh, non-uniform sand bed. This is before compaction of the bedding sand, before compaction, and this is what happens after compaction. After compaction, so there should be uniform thickness of bedding sand. So continuing our discussion on the construction. So once the blocks are laid above the sand bed, we have to fill the joints with the joint filling sand without much delaying. And how do we fill? We have to spray the sand and also broom the sand so that the sand gets into the joints. If weather does not permit, then we have to use the light sprinkling of water so that the sand gets into the uh, joints. So we have to apply this sand required number of times. And this giant filling should be completed by the end of the day's work. Then the last step, opening to the traffic. After giant filling, we can open the layer ICBP pavement to the traffic movement. In case if cement treated layers are used in the base, then allow curing for 7 to 14 days. You can also refer some of the MRTH guidelines for further specifications. Thank you.